of existing body of knowledge, existing scientific knowledge that actually backs up his idea. One of them is a law of a Christian Bohr that was a father of Niels Bohr, Danish, the guy who was working with the structure of energy in the atoms and the neutrons, he found out that his Niels Bohr's father, at that time he was known. His child was not really known as we know Niels now. But Christian Bohr already in 1904 made a law that actually, understanding this law, let us understand everything, how it's interconnected. The first line, you remember, of stress response is breathing. So Niels Bohr said, Christian Bohr said, he was a doctorate in the university, he was a physiologist. In 1904, he found out that, the blood is distributed, the blood distributes oxygen, in our body, right? But one thing is needed to actually give the cells, because the actual respiration is where the cells need oxygen, right? So cells require oxygen. So how do we optimize how the oxygen comes from the blood to the cell? He found out that, Christian Bohr, is that one thing that is needed to disentangle the molecule of the red blood cell, the molecule of hemoglobin, with the molecule of oxygen. They are bound very strong when they are in the blood. So in order to oxygen to get to the cell, they need to be disconnected. So the power here of their connection has to be lower. And he found out that the chemical connection that is regulating this is carbon dioxide. Carbon dioxide. Carbon dioxide is the gas that we both have in the air and we have into the lungs, in our lungs. And this difference is very, very big, 200 times different. We have 200 times more carbon dioxide here than here. So when we react to the stress with hyperventilation, when we actually start to breathe harder, when we start to breathe harder, what happens? We actually get less oxygen into the cell. That's called the Bohr law. Bohr law. And this Bohr law, it means that, you see, when you start breathing more, when something stressful happens, that you actually start to ventilate the lungs. Understand the word ventilation. Ventilate means there's more air comes through the lungs. In other words, you hyperventilate the lungs. Okay?
So you have less CO2.
So when you hyperventilate the lungs, you see what happens. And you will understand it right away now. You see, you have an atmosphere which is very big. That's the atmosphere of the planet Earth. And it's very, very big. And then you have something very little and sweet. What is it?
Lungs.
Is you, your lungs. You. And we have a smiley here. So this is the atmosphere of the planet Earth. So what is the most in the planet Earth's atmosphere? Remember what? How much oxygen we have? 20%, 21%, okay? So this is 21% O2, oxygen. So what do we have else?
Nitrogen.
Nitrogen, how much nitrogen?
most of it. It's not-
Right. 78% nitrogen.
In CO2, less
Actually,
than
N2. It's nitrogen.
CO2, it's less than 1%.
That's right.
0.8.
And CO2, 0.4. 0.4. So you know, all of us, we talk about, you know, CO2 has to go down, has to go down, has to go down because we have problems with it. And you know what? The last 100 years, how much CO2 the difference is for last 100 years? It went from 0.03 for 100 years ago to 0.04. That just shows what role carbon dioxide plays in the whole structure of planet Earth. You see what I mean?
It's 33%.
It's 100th of a percent in 100 years. And this 100th of a percent changed everything, the metabolism of our planet Earth. You have a question?
No.
Okay?
But I meant to say that the change
Yeah?
is very big. It's a third of it. You added to 3, 1. It is the change.
That's right, the change is, yes.
It's big.
Yes, the change is big itself. But you see, people think like many percent. They think normally, you know, how much CO2 we have? 30, 20. I mean, no, 100, 1/400th of a percent. You see? But you see, the change of 100th of a percent, which is a big, yes, it's a third, that's right, change everything in the atmosphere, in the metabolism of our planet. So, what do you think? So how is the atmosphere in your lungs? Let's write the lungs. Who is very good at making the lungs? Orna? Can you do it?
Drawing lungs.
Drawing the lungs. Small lungs. Very, it has to be nice lungs. Very sweet, nice lungs.
What I'm smiling.
Good lungs. Very small, like
Oh,
that.
that's too big.
It's okay. Very good.
I'm
Yeah.
smiling.
Smiling lungs. Very good, sweet. Very, very sweet lungs. Okay. But you see, we are putting the lungs inside of this. Very, very little thing, which is so you see, this little creature has lungs, very, very sweet lungs, you know. And you see what happens. We are actually connecting those two. We have an atmosphere and we have our sweet lungs. We are connecting it with a pipe. Da-da-da-da. We are connecting these little sweet lungs with the atmosphere. But you see, in our lungs, the gas balance is totally different. You see, how many percent oxygen in the lungs?
16.
16% O2. How many percent nitrogen? Nitrogen.
Like the same.
Almost the same, 77. Almost the same. Okay? We use also nitrogen actually. So how much the percent of CO2? Now we have 16 plus 67. How much?
5%. With the rest.
You see, here, you see, if you go 78 plus 21, come on, now, how much is it?
99.
99, 0.4. Then we have 1% rest. That's actually humidity of the air. It's a water humidity, you know, molecules, and very small gases like argon, like other gases. They take the 1%. We don't think about it. But here, you have 16 plus 77. Stress. How much? 83. Right? Fantastic. 6.5% CO2. To make you smile, really wholeheartedly smile, you need 6.5% CO2. Yoo-hoo! You see the difference between 4% and 6.5% CO2? How many times difference? More than 200. No? No, almost. 100, 150. Okay? 150% difference. Okay? So, do we connect these two very, very big one atmosphere of the earth and this small smiling, still smiling lungs? Do we connect it directly? What will happen if we connect them directly? You know about physics from the school? You connect two how do you call it? Containers together, and with different kind of liquid or gas. What will happen? One is big, one is small. Huh?
They will mix.
They will mix. They will be the same. So the 6.5 will go down. Right?
To about the same.
Right? 6.5 will go down to 003. Is it possible for us, when these go down to 003? No. We'll be stopped on the way. We will die at 3.
At 3?
Already at 3. At 3%, we're going to die. So, how do we prevent that these two containers are always connected with each other? So we can, actually this one is, we have to remain at this, to remain smiling, really smiling, wholeheartedly, you know. What do? We have a mechanism called breathing. Woohoo! Because if we didn't have a mechanism called breathing, it would equalize and we will die. Because you see, Professor Buteyko made actually a table, very, very nice table, when the 3 is the last one, and the 6.5 are in the middle, and that is CO2 in the lungs. This is called normal. Norm. Now this is called death. Death is big because that's why we have a death at 3, normal here. Below 6.5 is disease. And over 6.5, how would you call it? The contrary of disease. You have normal, you have disease here, and after normal you have super health. So what we are going to do now, we're going to go out and start moving on the way to super health.
But usually all the quantities in the organ, in our organism have some good range, and below it and above it, it's not good. And here you
I could tell you, very good question. Very, very good question. That's a very good question, because you see what happens. When you go 6.5 and you go to 7.5, here, what we call a normal pH regulation. This level, what is normal? The pH regulation is normal. But you see, pH is very, very different places in the body. And pH actually regulates all the systems in the body. It's one of the first things. What breathing regulates, it regulates the pH level. It's not regulating the pH level. It's regulating the normality of regulation of pH level. That's a very big difference. So pH level of the blood, for example, lies in a very, very shallow range of 735 to 745. When it goes 35 to 745, yeah. If you go up, You call it acidosis, because alkalosis, because alkalic up, you know, from 0 to 14, alkalic up, and acidic down. You can also call it basic, right? So what you actually regulate, the first thing, is acidity of the blood. That has to be in very shallow range. And when it goes down from 6.55 down, your blood becomes alkalic. It goes down. And the situation is, I will tell you how. Alkalic, because of breathing,
When it goes
it goes up.
up,
From
it's
745, it goes up. Huh?
Up alkalic. No?
Up alkalic.
Up.
It goes up. Yes. You see blood. You see pH of the blood here. 735 to 745. Very shallow range. When it goes down, you know, it's acidity, acid, and here we have alkalic, okay? This one we call acidosis, it goes acidosis, and it actually affects immunity, it affects how the nutrients are distributed to the joints. It affects how the toxic stuff is taken out of the cell and disposed. A lot of things. You see, normally it's called metabolic acidosis. And this is called respiratory alkalosis. I will tell you roughly how it works afterwards. See? So what problems we have here? We have when we reach 8 and when we reach 6.5. We have problems here, guys. What happens? If we reach 8 in respiratory alkalosis and we reach 6.5 in metabolic acidosis, either way. It's the same thing, because this one happens actually, it's not, when you have respiratory alkalosis, you have actually metabolic acidosis at the same time in the how do you call it, in the body. But both things we're talking about, it's not really right, in respiratory range. We have here 6.5 or 8 in respiratory in. Both of them correspond to death. Both of them correspond to CH of about 3%. It's very rough what I'm saying, but what happens? When the acidity of blood changes, and what you regulate with your breathing is the pH. When the acidity of blood changes, this is called actually respiratory acidosis. Oh, now it's good. Perfect. Respiratory alkalosis and metabolic acidosis. That's what is interesting for us, because it happens at the same time. Your body becomes acidic, more acidic, and your blood becomes alkalic. Those two things, they are connected together. You see? So we need really to this to happen. Now I can write 6.5 here. Yeah, very good. Okay? What I wanted to say You don't need to understand because right now I will explain it 100%. What I want you to take it for given that the blood has to remain in very, very shallow range, and all the normality in your body is dependable on this pH in the blood. And in order to let it in the blood, we have something here. It's called regulatory. It's a kind of a, how do you call it? The valve. The valve. Boop. The valve. Boom, 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 boom. It's not a, well, it looks like a flower. It's not a flower, it's a valve. Okay? And this valve, automatic valve, and it's breathing. So the valve is working when it's normal, is working 12 times a minute, opens and closes. 12 times a minute. How much air? How much air 12 times a minute? How much air? No, per intake, per air intake. Half a liter. Very good.
And divide it.
Very good, very good, very good. So you see, 12 times a minute, half a liter. When you start hyperventilating, which means you have more air, very often, that is normality. This is normal breathing. You see? When you go up from there, your blood, the first thing that changes, and it triggers everything in your body. The stress response, the physical resilience, the mental resilience, everything. I'm going to take you how.
So the blood get alkali.
Yeah.
Because the CO2 lowers the pH. More CO2, lowers pH.
Yeah, you see, it's because when CO2, it's chemistry. I will tell you about it. I will tell you. It's about what kind of chemical connections carbon dioxide comes in. It's not a gas actually in the blood. It's a fluid. And what it's like a bicarbonate H2CO3, and it's what shifts actually the acidity or the alkalinity. It's what kind of connection a CO2 travels in blood with, you know. So what happens is now, you see, we are because of stress the last 100 years. It's not only the atmosphere of the earth changed, because we, some people, we induced a lot of changes to the earth atmosphere. People say that's because of that, because of the industry, with pollution. But we also polluted, we also changed a lot our way of breathing. It's the first line, because of stress. So we stress the nature, and we stress our physiology. And what happened the last 100 years? This 6.5 that was in physiology books for 100 years ago went down to 5.5. .5% now, 6.5% 100 years ago, 5.5% now. And that is very good, the green one. And that is very bad in a way, you see? But it's what normality is now. 100 years, normality is 5.5. But I can tell you, because I'm working with cancer, I saw already a couple of times that the cancer, when you reach to the 6.5% CO2 and 6.5% CO2, I can tell you how it's measurable. By Buteyko method, the cancer reverts.
So your answer to my question is that you don't need to have more than 6.5. You need to take your system from the low level of CO2 to
Yes.
the system.
Because the most people have, what would you say,
Something
The-
was wrong there.
90, yeah,